Hello all, and welcome to a tutorial video that is going to explain why we use multiple files in C++ and how to turn this game I made into, well, multiple files. For one, the reason why we split up our projects is because all of this code here is currently in one single file, and you can see they define a lot of different things. Let me demonstrate what this game is real quick. I just made it on the spot for this video. However, there will be another video that's going to explain this game specifically here. So you can see here, it looks like an invaders game, where we have a player at the bottom that can shoot bullets, and we have an enemy mob that is slowly coming towards us. It's a pretty simple game. There's not too much to it, but I'm not going to go into the details of how the game works, as today we're focused on a bigger picture. We're getting to a point where we want to expand the game, we want to add new features to it, but we're realizing that this file is getting a little lengthy. And as you work on your project more and more, you'll realize that things might depend on each other, and that you have too much scrolling to do. You're going to need like multiple windows to see what's going on. Like you want to work on an enemy, but the enemy's way up here, while all the code you need to write for an enemy might be way down here. There's just a lot of unnecessary scrolling and time spent moving around. So the first reason that we want to split up the project is to segregate some of these components so we can go to a certain file instead and work on them. The second reason to do this, and more importantly, is that in the future, you're going to want to use stuff from different classes in other files. And let's, for example, say players, actually everything here, enemies, players, they all depend on this rectangle class I made right here. And at some point in time, you may come across this needing a dependency from something else and realize that you can't actually do it because you defined it afterward. What I mean by this is that if we were to just run this, we would get a build error now. What did I do? All I did was move this down here. And so what this is saying in code is that this class is now undefined. So reading the code from top to bottom, we don't actually know what this class or struct is right now because it hasn't been defined yet. And that's where we can talk a little bit about the subtleties of declarations and definitions. So if I just type struct rect here, this would be a declaration of sorts. This is saying this exists, but we haven't defined what it is yet. And this in itself is valid enough for these to recognize that there is some type like this in existence somewhere. While this would not only say that struct rect exists, but that it is defined with these properties. And this becomes a declaration. But you see here, we still can't use the code because declarations only work as a means of saying something exists, but you still can't access its properties. So right now, the code is complaining about how we can't access them. And so you need both, right? If we want to access the x and y and width and height parameters of said rectangle struct, we need to know that they exist. So when you're dividing up your files, you have to keep in mind that the declarations are needed and the definitions are needed by the compiler to actually work with the program. And we'll see what we mean in a minute when we start actually splitting things up. So we already know we're going to depend on this rectangle for both enemies and players. So we know that it needs to go in its own file, and I'm going to start with that. When adding multiple files in Visual Studio, you can use the built-in add feature like I did. You can right-click source files and type in the name of your source file. So here I'm going to type in rect.cpp. I'm just going to call it what its struct is. That's probably the easiest way to remember what's going on and move into here. And it seems like I can just cut and paste everything into these files, but we're going to explain why that doesn't necessarily work in a second. Let's talk a little bit about includes here. You see I just copied this into here. When you type in include whatever file in quotes, what you're going to find... so this isn't normal. We're going to explain what this is actually doing in a minute here. But I basically said include this rect.cpp file in this source file. So if I run it, you'll actually see it works. But this is unusual. Most of the time what you expect is a header file. The reason why this works is you can think of includes as like a copy-paste. What I typed in here, the compiler will just literally take this and say, oh, okay, put a copy of that right here. And as we demonstrated before I split this into a separate file, that actually worked. That's valid code. So you can think of includes as just copy and pastes from one file to another. However, this is not what we want to accomplish, because what happens the moment we split up enemy and player? Well, let's try to do that first. So I want to put enemy and player in their own files, clean up the code a little bit. You know, it seems like a reasonable thing to do, right? My enemy class, I want to here, and my player class, I want to here. So we can repeat this process of adding files multiple times. And we'll already notice some issues. But let's do what we did here and say we included these two, right? So it, quote unquote, works like before. So we're still getting errors here. Why? Well, both enemy and player rely on other things from other files in order for the compiler to know what to do. Because if we try to run this, this is what the errors look like. Just tons of syntax errors, and it's saying like pause is undeclared, player illegal member initializer, OLC is not a namespace. Like it just can't find anything. And why is that? Well, in C++, everything is usually split into headers and source files, where the headers define all the declarations and the CPP files define the actual definitions of what those contain. So, we can try in the source files then. It might make sense to include a header file, right? If we include my OLC pixel game engine.h file, which has the OLC namespace in it, it should make these go away. So you can see my IntelliSense has caught up here and remove those. So we say, okay, let's do the same for rectangle. Now wait a minute, we don't have a header file for rectangle yet, do we? Well, we can try doing what we did before in here and including rect.cpp, which does contain the definitions for these. And we'll do the same thing for enemy. So you can kind of see I'm trying to explore and nail why it's important to do what we do here. We're going to try to run this. And you can see it works. Works just fine. And that's because right now we've copied this into multiple places. But this is still not ideal. Because what happens when multiple of these files exist in multiple places? You're going to just end up with these everywhere. This struct rect int x, y, w, h with function definitions everywhere. We haven't really talked about that yet, but let's see. Do multiple things rely on... bullets. No, they don't. So let's say we're going to be adding... Oh, I'm going to make these private now. I'm going to be adding two functions here. One to specify a rectangle. Basically, I'm making a constructor here. And in my constructor, I'm going to initialize all the variables. And this is how you would go about doing that. I'm just setting all the parameters, x, y, width, and height, to whatever is provided in the constructor here. In addition, I'm going to make a function that returns the position and the height values for this rectangle. And because I'm going to be using this vector 2D from OLC Pixel Game Engine, so I'm going to have to include that as well. So get position will return both x and y together. And get size will return the width and height. Once I do this, I'm going to have to refactor things a little bit, because now these are no longer accessible. Like, we can't type .x, or excuse me, arrow x and arrow y. These are pointers, by the way. So I have to use get pause, and you can see get sprite pause relies on a vi2d for a return value as well. So one cool thing we can do is replace these with the appropriate functions here. Sounds good, right? Cleans up our code a little bit. Same with enemy, or player, excuse me. I believe the main game also relies on some of these, and may need fixing. Nope. Just player and enemy do. You can see the game still works the same. Typical way to split these up into declarations and definitions is all of these just get declared somewhere else. Just the parts without any of its definitions inside the braces here. So I'll show you now how we go from one CPP file, which is what we've been using so far, to a header and a CPP file in preparation for future project stuff. So here I'm going to type in rect.h, which is going to create a header file for our rectangle. And typically I just like to start by copy pasting what we had. And you'll see Visual Studio just added in a pragma once. Keep that in there. That just keeps multiple include things from happening. And then I'm going to delete all these definitions here, the stuff inside the braces. We don't need any of it inside of a definition file. Also, this header still relies on the Pixel Game Engine include because it uses these OLC vi2d classes. So this would be what a typical definition file would look like. It doesn't say what these do, it just says they exist somewhere. That way the compiler knows, hey, you don't have to worry about declaring it again, it's going to be declared somewhere in your program. But that changes the CPP significantly because we can't declare a rectangle again when we've already declared it. Because typically what you're going to do in the CPP file is say, okay, rectangle exists here. And I believe once you do this, the compiler is going to get very confused because you are now redefining what a rectangle is. So how do we avoid this but still specify what these things are? Well, there's a special syntax. For each of these functions, you have to type in what the object it's referring to is called. So I'm going to put rect, and I'm going to put colon, colon, and then I'm going to type in the function as we see in the header file. When I do this, we're saying reach out to wherever this struct is, grab this specifically, and set its definition to this. And then we can specify something in here if we want to. In our case, we want to make all the parameters equal to their local parameters. So I'm setting the x to x, the y to y, the width to width, and the height to height. And that's all I'm doing here. This is just C++ syntax. We can do the same for the other two. So instead of typing get pause, we want to type rect : get pause. And then here we would define what we're returning. So again, I'm returning the x and y position. This is the code from earlier. I'm going to get rid of it in a second, just using it as a reference. And finally, we can do the same for the get size function. You might be thinking at this point, isn't this a little redundant? It kind of is, but this is typically how you see C++ files split up. You have the header defines what exists, and then you have the CPP file, which defines what those definitions actually do. Now, we don't want to include the CPP file anymore. We want to include the header file, because if we include the CPP file, things are going to be a little more confusing. I think it still runs in this instance, but this is not proper. You don't want to do this across multiple files. It's very redundant. But what we've done here is we say, okay, reach out to the header file. It has the things you need in it without including all the declarations. You can see it compiles. It's happy enough to combine everything together like that. We can continue splitting this up further into the player and enemy definitions in the same way. I am putting these in the wrong place. Player and enemy header files. Yes. So you can see I didn't make my Visual Studio think this was a header file, so that's fun. But I'm sure it'll figure it out. I hope anyway. Oh, I see. There's a hidden space here. That's my bad. Now it thinks it's fine. So we'll do the same process again, and as you do this multiple times, it'll become easier. So I'm going to take my player class that I made from earlier, and I'm only going to include the definitions in the header, not the declarations. So in this case, we're removing this portion and just having the constructor look like this. We're removing all of this. So only the definitions of each function remain. Now in here in the CPP file, we're going to include player, and again we want to avoid those multiple redefinition errors. So we're not going to be using this, but we're going to be using the syntax that defines all these. So I'm going to actually do this the opposite way this time. I'm going to delete that, and I'm going to add in player : in front of all of these function names. Like so. And by doing that, we've essentially turned it into a proper CPP file. You can see I typoed this here, replaced the O when I should not have. But there we go. Split that up into a header in a CPP file. You can also see here, the include for Rect is not in here. So I believe this is going to cause problems right now, depending on the ordering. Yeah. So a lot of times with linker errors, you're going to see, well, for one, the code is going to say LNK something. And here we can see there's the messages can be kind of cryptic. They're showing like the debug or the function symbols that the linker is trying to deal with. So saying things like player already defined and player.object, and yeah, can shoot player already defined and player.object. It already exists somewhere. So if I go looking in here, remember we're still defining these CPP files. So guess what? Now we're trying to use, this is the example I was trying to say earlier. We're going to run into problems eventually, including these quote unquote CPP files, because we're going to have this trying to be placed in multiple areas. It's going to be defined here, and then it's going to be put in the shooter example here, and now we have it in two places, and it's going to be very confused. So this is why we switched to including only headers. Because what's going to happen now is instead of the compiler copying this in multiple places, now it's going to be copying this in multiple places. And when I say copying, that's not necessarily what it's doing, but we can think of it that way. It simplifies things. And since we're not redeclaring all of these, we're just saying they exist, now we can safely include this file, this header, not the CPP file, in multiple places, and it'll be okay. And a lot of times when you're first splitting up your project into multiple files, if you're running into these multiple redefinition linker errors, that's why. Because you can't have the compiler expect these things to be in multiple places and figure out which one to use. And this is how we remedy it. We split up our files into CPP and header files. So I'm glad we got to see a demonstration of that now that we've kind of refactored that. And we'll be doing the same with enemy. We should see the same problem here when we first split it up. So here's our enemy CPP file right now. We want to split it up into headers. So we'll take this and we're going to delete all the definitions right now. We only care about the declarations. So this time I'm gonna do something a little different. I'm gonna multi-select here because most of these are the same, and hold down Shift and delete those two rows like that. Sometimes multi-select can be useful if you can find a large chunk of code that all needs to be updated at the same time. Once again, this has two dependencies, so you want to fulfill them by including the appropriate headers here. It's not popping up the helper. There we go. Control space, by the way, is your friend when you're not sure what to type or you need the hint. Control space will pop that up in Visual Studio anyway. Other IDEs will do the same with different shortcuts. And then we're going to be turning the CPP file into, well, the declarations of those things. So we're going to go ahead and add enemy : in front of all of our function names. If I can multi-select here, like this, we're going to get rid of all the definition stuff, like so. And finally, we have to recognize that this is enemy.h, and I'm not going to include rectangle here. Now, including it doesn't actually hurt. That's kind of what the pragma once is responsible for here. It tries to make sure, hey, we don't need this anywhere else. But the reason why I don't have to include these two here is if you look at this header file, I am including Rect and OLC Pixel Game Engine when I have the header enemy file here. Now, because pragma once is smart enough to figure out, wait, these two are already defined, we don't have to define them again, we don't necessarily have to worry if we include these anyways, it's just redundant. You can see we still have errors, because once again, there's redefinitions of enemy. So we're going to get rid of CPP here for the main program and only include the header now. And, oh, did I? Yep, right here. Make sure you don't include defaults in your definitions. Same with the constructor up here. These equals ones have to only be in headers. So I'm glad there was a default parameter here. It shows that off as well when you're moving stuff from your single file to your headers, like so. So at this point, we're almost done. We just have one more class that I want to split into its own file. But you can see in the enemy.cpp file, if I were to remove these two includes, it compiles fine. And now we can go back to the player and do the same thing, because the player header, or what I thought the player header did, was include them. Now this is interesting. I can show you this actually. The way I did this here was I included the player header after I included these two. So the compiler is happy enough to use that as a way to get what it needs. But the moment I delete these two, now this is complaining because it's out of order and not able to find those two. Personally, to keep things organized, every dependency that a header needs should be in the header, not included out here, outside the header. That to me doesn't really make sense because both player.cpp and the header file rely on it. So if you're going to include the header anyways, you might as well put the dependencies that both need inside the file, inside the earlier file, so you're not putting it out here, and then every time you want to include player.h, you have to include these two as well. So just a little bit more header cleanliness here. So you can see the game runs just fine still. You don't have issues there. So to top it all off, we're going to be moving bullets as well. So first I'm going to be removing bullet out of here. And I'm glad I made a little example where I get to show this like 4 times. It just really reinforces what we have to do here for the process. So in the CPP file, I'm going to put this old block of code, and then I'm going to make a new bullet header file. And I'm sure when you turn your project into a multi-file project as well, you will quickly realize that it's going to be a little redundant and repetitive at first to do all this, but you'll find your project will be a lot more manageable as it grows and grows. You don't want to keep everything in one file, and it's going to be a nightmare to manage. So bullet.h will include its dependencies inside of the file again, just like we mentioned earlier with enemies. And you'll notice something interesting. Bullets have a function that rely on enemy here. So now we can actually include the enemy header file here. And the compiler will know what an enemy is. Very nice. We have that dependency solved because we split this up into multiple files. If we did not, then we'd run into issues because now we have to declare, we basically have to copy paste all of this. Anything we want to use about an enemy, we'd have to copy paste into this file, and then we'd have to do it manually. And like I said, that's what the header files are good for, is now we need this in multiple places. We don't have to copy paste it everywhere. We just include the one file. So very good example here. So bullet.cpp needs its counterpart, its header file here. And then all of these dependencies will be solved. And so finally, our main game file does rely on the bullet class as well. Now it doesn't know what it is, so we include that header file inside the main project here. I should have mentioned this at the beginning of the video. I kind of wish I did. But if you wanted to follow along with this specific example, and I'll include that in the file description or video description as well, I do have this on a repo. So it's not this actually, but it's a shooter example. So yeah, I will include that link to my shooter example repo. in case you want to follow along and try to refactor this game as a test, like I did here. That way you're prepared with a... Oh, we have a redefinition of bullets somewhere. Oh, yeah, so I did a boo-boo, a no-no. Don't do this. Like I said, looking at a reference from our other CPP files, make sure you are only including the declaration portions at this point. Don't redefine a class. Yep. I just forgot to come back here. So typing bullet colon colon in front of all those, like so. That way we don't redefine those. Looking good. Game still works just fine. Aliens are doing their thing. Enemies are, or players doing their thing. Bullets are doing their thing. And they're all handled by this game. Just a quick recap. I'm going to be having another video again that goes over this game specifically, or creating this game. But what we have here are all of our includes now are in their own files. The game itself has a sprite sheet, so it's not really clear from just seeing the game in action. But the game itself relies on this little image right here, like a really tiny image, because these are pixels here. You can see the enemies are located here, and the players located here. And so, because of that, I have decided to use a sprite sheet which defines all those rectangles, the mini sprites, if you will. We got containers for the enemies and bullets, we got a place for the player, and a couple of game state variables. Then I went through, loaded everything, placed all the enemies on the field, and then in the onUser update function, which is the Pixel Game Engine's like step function or update function, I'm going to go ahead and close these now since we're done with them. In the update function, we do have specific update things to do for both bullets and players. We also update all enemies in a zigzag pattern. That's what this statement accomplishes here. And then we have some player inputs. And finally, we render everything. And inside here, we also handle bullet collisions. And finally, if there's any invalid enemies or bullets, they get erased from the game. Yeah, I'm not going to go into the code today. That would make the video a lot longer. Stay tuned for another video that actually creates this game and explains the thought processes behind how I made all these and how to do them. I think it's a pretty clean and simple implementation of this shooter invasion-like game. And now we've split it up into multiple files. So if we wanted to expand on this game, now it's a lot easier. You can see this source file is now much smaller, being only 138 lines of code instead of the original 250 something. So yeah, I hope this was helpful, and stay tuned for more.